In the previous video, we've talked about the velocity of money, and we said that the velocity of money can be given by price times y, which is our nominal GDP, divided by the money supply, or the quantity of money. Okay, if you rearrange this equation slightly and cross multiply, you would get money times velocity equals price times y. And this equation is usually referred to as the quantity equation. This is because it relates the quantity of money to the nominal value of output. This is your nominal GDP or nominal output, P times Y. The quantity equation also shows us that an increase in the quantity of money in an economy must be reflected in one of the other three variables. So if we write this down, we can say money equals price times Y divided by V, which is velocity. Right, this guy is velocity. Then if prices rise, the quantity of real GDP rises, or the velocity falls, all of these three things would lead to money supply rising. Okay, so what we can do here is we can actually take a look at what does velocity look like for the US economy. And so velocity again is just measuring the number of times a dollar changes hands. And in this graph, you see velocity as so the money supply that we're using here, or the measurement of money, is called M2. You're familiar with M2, which is the sum of M1 and other savings deposits. Now, notice that the gray shaded bars here represent US recessions, and you're looking at velocity, which is sort of this ratio between nominal GDP and money supply. So we're measuring this over time for the US economy, and what we find is that velocity is higher, or it rises in periods that are in these white areas, which are expansions. You see this is rising here, and velocity usually falls during recessions. So the typical dollar doesn't change hands as many times as it would during expansions. And this makes sense because if the economy is doing well, there are more transactions taking place, etc., you would think that velocity is higher. And in times of recession, you would think velocity is lower. Okay, so this is telling us that velocity in 1959 was 1.7, which is to say that $1 would change hands 1.7 times, or approximately 2 times per year. And here this is saying velocity is fallen if you're looking at 2019 quarter 4, which is about 1.4. Okay, and it was the highest here in quarter 4 of 1997, which was about 2. So if you think about it, while we're seeing this going up and down, we can easily say that the ratio doesn't change that much. Okay, so it is really between 1.4, which is the lowest value, and 2. Okay, so it's not varying that much. It's relatively stable. Okay, so one thing we can say is velocity is relatively stable over time. Even though we see those fluctuations on a log scale, those are very small values. So this takes us to understanding what is necessary for inflation and the price level when we try to infer things from the quantity equation. So how do we explain prices and inflation from the quantity equation? Again, we can write down m times v equals p times y. You want to keep that at the back of your mind. This is the same equation we were using with velocity. So the first thing here is that velocity of money is relatively stable over time. Velocity of money is relatively stable. Second, because velocity is stable, whenever the central bank changes money supply, it would cause a proportionate change in the value of nominal GDP. So when the central bank changes money supply, or M, which is the quantity of money, it causes a proportionate change in nominal GDP or nominal output, which is equal to P times Y. Now we know that in the long run, real GDP, which is Y, is determined by labor, capital, physical capital, human capital, and natural resources, and technology. And we also know that because money is neutral, in the long run, money is neutral in the long run, so it does not affect Y, which is a real variable. Okay, this is real GDP or real output. This is a real variable, so it's not going to affect Y. So then what are we left with? If you look at this equation, if V is not changing, and Y is not changing because of money, money in the long run is going to cause prices to change. Okay, so when the central bank changes money supply, we can just call it M for now, or the quantity of money, these changes are reflected in the price level. Therefore, when the central bank increases money supply, the result is inflation. And this last result, inflation or an increase in P, this last result here, is the same result you had when we were considering the money demand, money supply equation. Graph.